Thank you. I forgot her name. Arpita, right? Yeah, thank you, Arpita, for the kind introduction. I should keep it here, yeah. I'm super happy and excited to be on this stage today to tell you about a fascinating application of computer science called mixed reality that I have been studying for last 8 years. Although popular media often associate mixed reality with the future of entertainment and gaming, the commercial success of this technology has been driven majorly by its ever-grown usage of manufacturing sector. My role in Grid Raster gives me a front seat to witness the bleeding edge of this development, and in today's presentation, I'll give you a glimpse of its exciting world. We will cover the core concepts and discuss some important problem statements. I'll also share some results from my research on the problem of non-rigid point cloud registration for mixed reality. So first, we will dive into some core concepts of mixed reality. Okay. Yeah, so what is mixed reality? So mixed reality, in short, we call MR, is a technology that merges the real and virtual worlds to produce new environments and visualization where physical and digital objects coexist and interact in real time. It's essentially a spectrum that encompasses both augmented reality and virtual reality. AR. AR, which is augmented reality, overlays digital content onto the real world. Think of Pokemon Go that many of us might have played. VR, the second one. So, okay. VR, that is virtual reality, immerses user in a completely digital environment like a video game. MR sits in between, allowing interactions with both real and virtual environment. That's what I work on. Imagine wearing a headset where you can see your actual surroundings, but also interact with holographic objects or virtual interfaces that seem to exist in your space. I'm not sure why this video is not playing. Yeah, so this is one of the maybe a demonstration of from our team at Raster. So this video showcases like how we can track dynamically any 3D model in real life. Yeah, so this is a 3D scan. Okay. Yeah, so next I'll talk about computer vision. That is my domain. So yeah, let's, 1 minute. Yeah, computer vision. So AI algorithms used for converting raw visual signals like images, 3D point cloud into meaningful objects. Their relationship and their semantic constructs that helps us understand the world around us. So there are three critical components for mixed reality. So we can just pen it down like computer vision underpins critical mixed reality functions such as spatial mapping, rendering, and interaction. So these are the three components that we should be aware about if we are building solutions for mixed reality. Or let me rephrase it, if we are building computer vision solutions for mixed reality. So now, why is mixed reality relevant in manufacturing? So yeah, the first one, the visually and dimensional inspection in quality control. So in safety critical industries like aviation, every component goes through stringent quality checks in isolation and as an assembly. The quality check phase is a significant contributor to manufacturing latency. So yeah, there is visual inspection and dimensional inspection. So these are the process that it goes through before it, during the manufacturing inspection process. Manual inspection can be blocked by subjectivity and distraction. Okay, let us go to now. Yeah, leveraging digital twins for visual and dimensional inspection in quality control. MR can overlay the ideal CAD model of a part directly onto the physical object. This allows inspectors or AI to instantly see an deviation from the design specification. So we can do real-time visualization and comparison, as well as virtual measurement tools are available so that you can measure like what is the defect, what is the height, actually what is the volume, everything can be measured in real time. And also we can have dynamic feedback that can be saved as an metadata, and we can prepare a report and send it to and upload it to the server so for the entire team to access it. And the last one, the automated report and data integration, that is what I was talking about. So yeah. So yeah, now we'll talk about mixed reality for remote collaboration and training. How is it used? So first one is like guided inspection. The second one, remote expert support and the simulated environments. So guided inspection, yeah, what it is, like overlaying step-by-step instruction, diagrams, CAD models directly on the physical objects. The second one, enforce a standardized inspection process, reducing the risk of the overlooking important details. Same, second one is report expert support. That is basically technicians can share their view with a remote expert in real time. That saves a lot of time if you are doing it manually as compared to you do it in MR. A remote expert can use virtual hands within the technician's field of view to demonstrate. Next comes the simulated environment, how they can help. So immersive virtual training environment can be rendered around workers where they can practice operating real machinery. Adverse real-world consequences can be avoided. So mixed reality has been shown to accelerate the learning process and improve knowledge retention. Now we will quickly just take a glimpse of mixed reality hardware. Yeah. So there are multiple sensor type that is available. I'll just quickly cover it. So there are cameras, depth sensing, eye tracking, hand tracking, head tracking, and other sensors are also there depending on the device. So here I think we can see a comparison for Microsoft HoloLens 2 that is widely used. But the second one, Meta Quest Pro, and the third one, Apple Vision Pro, that is very new to the domain. So what is HoloLens 2? HoloLens 2 has a dedicated depth camera and focuses on hand tracking, which is crucial for its AR interaction in industrial settings. Quest Pro is from Meta, that was previously Facebook, relies heavily on grayscale cameras for both tracking and depth sensing, providing a wide field of view for VR experiences. And Vision Pro is from Apple, has the most extensive sensor suite with a strong emphasis on visual input and eye tracking. Its LiDAR scanner enables detailed 3D mapping of the environment. Next comes the display technology. So here, so we have, feature-wise, we have display technology that can be your LCD, waveguides, micro OLED, then comes resolution, field of view, refresh rate, lens type, and eye accommodation. Yeah, so here, yeah. So next thing, next slides will where I'll cover my research domain. So it is point cloud registration for CAD model overlay, where that's where AI meets mixed reality. So yeah, what is point cloud registration? So in the slides, we can see on the left side, we have two point clouds, or you can see two, like maybe, yeah, the input point clouds, that is source and the target. And on the right side, we can see the registered point clouds. Basically, like what is point cloud registration? If I want to explain that, it is more about finding a spatial transformation function that results in point-wise alignment of the source and target point cloud. So, and I also have the transformation functions, like how the rigid registration works and how the non-rigid works. So basically rigid is like something which is not moving, and non-rigid is like maybe ourselves, right? So our hand is moving, so we are the best example of non-rigid registration. So we'll move to next slide. Yeah. So this is my one of the work that got accepted in CVPR 2023 last year. So this was part of my master's thesis, and the work was the name was Power Align. That was what it was. So I can just talk about it a bit. So it is an efficient way to register, or we can say do point cloud registration for part-wise rigid bodies, or maybe for rigid objects which has moving part. So here in this slide, oh, sorry, I should have moved there. Okay, yeah, sorry. So yeah, here in this slide, so this was the power line that I was talking about. So this was the work that got accepted. And yeah, so here we can see there are maybe, if anybody can guess, this is a lander, NASA lander, the lunar lander. So I kept on working on this for the entire paper. So you can see two CAD models or the point cloud in two different colors. So basically this is the source and target. Then maybe I can explain like what are the steps I took to achieve a part-wise registration for this model, because it do have moving parts. Yeah. So first of all, we construct a source part graph. So part-wise, we have a graph, and for the entire part, we have a graph that we input it to the registration module. So we can see here, wait. Yeah. So maybe, yeah, let me just go through this slide as well. So yeah, this was the second component of my work, where we were actually doing the correspondence matching. That is very crucial for point cloud registration. So basically, we need to find the correspondences between source and target. And then, yeah, then comes the next thing, which is like, okay. Yeah, this was the, I missed it, sorry. Yeah, so this is where we are doing efficiently, we are doing part-wise registration. So you can see that we are just trying to align the moving parts one by one so that it aligns completely. So if I go to next slide, so here step by step, like I'm trying to show how the antennas or how the all the moving parts that we have, like we align it one by one so that in the end it looks, yeah. Yeah, so this is one more example of a robo. So I had a robo at my place, so I was just working with that. So I had different cases or different settings, we can say, where we have non-rigid deformation in one part and some noise, and if we are still able to align that using the power align algorithm. Yeah, this is the setting, second setting, where actually we added some more noise in multiple parts, and then we were able to get a good registration. Okay, so this is, I think, more about the work that I did. Now I'll come to how it applies to MR. Okay, So here I have a small slide to showcase what we do at Grid Raster and what end-to-end mixed reality platform looks like. So yeah. Yeah, so what do we actually do? So we enable industrial digital transformation with the power of AI, XR, and cloud computing. So we have the first use case that we showcase is Grid Raster digital twin compatibility. So what do? We create content 10x faster at 1/10 of the cost. We can rapidly scan and create digital twins with commercial equipment, unlocking the potential of real-world data and immersive experiences. We also have GridRaster AI-enabled dynamic XR that understands and aligns objects with millimeter accuracy. The third one is GridRaster Workspace. So that helps scale XR sessions to thousands of users worldwide in different geographical locations. The fourth one comes the GridRaster Spatial Computing Platform that creates, processes, understands, and distributes 3D data seamlessly. So last but not the least, I do have so yeah, this is another collective demo of all the work that we do at GridRaster. So here this is a physical aircraft rib. So we'll try to align this and find the defects or anomaly on top of that. So these are the anomalies or the unwanted objects for the rib. And now we can see how it detects it. So whatever we see it in red, that was anomaly. So these are the missing bolts that we can detect very easily in fraction of seconds. These are all the real aircraft parts. Like I was talking about, we can export the defects and access it from anywhere as a report. this is a 3D scan of the aircraft cockpit using our technology. This is in VR. Yeah, thank you everyone for your attention. Feel free to reach out to me at the email ID and also join my wonderful team at the Trust. Thank you.